Okay, so let's continue from where we stopped. Alright, so we are going to express this equation. We can also express it in this form as well, yeah? Now over here we can see that we cannot transform, or we cannot express this equation as a linear equation keeping y as a dependent variable. It's not possible for us. We cannot express it. So one thing that I need to share, I must say, that in first order differential equations, it is permissible for us to interchange the variables according to the requirement. We can interchange the variable and we can put one variable as a dependent and another one as an independent according to the requirement as per our need, okay, after analyzing the equation. So over here, as y is not going to help us in expressing this equation in a linear differential equation form, so if we just take the reciprocal at both sides like this, okay, so it can be expressed now. It can be easily written in this way. If I just split the right hand side, it can be written in this way, yeah. And therefore I can switch this term on the other side. It becomes 1 upon y times x equals to 2y squared after canceling. Alright, so now you can observe that this is a linear form. This is a linear form where x is behaving this time as a dependent variable and y is behaving as an independent variable. Alright, so over here you can see that your p of y, this function is minus 1 upon y, and your q of y function is 2y squared. Now we are going to obtain our integrating factor. The integrating factor is going to be expressed as mu of independent variable, just mu of y, and is equals to exponential raised to the power integral of your p of y dy. Alright, so over here my p of y is minus 1 upon y. It's like this, dy. So I can write it as minus ln y. Alright, and I can write this negative sign at the power of y following the rule of my logarithm. So it can be written something like this. Now exponential is going to cancel out the effect of this logarithm, and I'm getting this thing as my integrating factor. So mu of y is y power negative 1, so it is 1 upon y. So this is your integrating factor that we are going to multiply with this, with what? This equation, okay? We just call it equation number 1. Alright, so when we multiply this equation with our integrating factor, so I'm going to multiply both these things and this thing. I need to just slide my page a little bit upward. Now it's easy. Okay. And minus 1 upon y times x upon y equals to 2y squared times 1 upon y. That's it. So you can see that this is the derivative of your x times 1 upon y. Alright, and this is 2y. That's what is left. Alright, so when you take the integral at both sides with respect to independent variable y, you take the integral. I hope you have understood now that once the theme gets cleared related to any topic, then it's not hard for us to simplify the exercises. Alright, so what basically the thing that is crucially needed is the clarification of concept. So now we are simply having x upon y left here, because an integral and derivative are going to cancel out their effects. So now the integral of y is y squared by 2 plus some constant. Okay, this and this gets cancelled. So what is left here? Let's do the work at this portion. So x by y is equals to y squared plus some constant, and as we have discussed that y is our independent variable, x is a dependent variable, so we can express this equation just in terms of x, because you can see that x is independent variable and it's the function of y over here. Okay, so our objective is to get the function of y, that is x. So just transform this equation keeping just x as a subject. This is gonna be your final form, and that's how you solve. So this is the solution. This is the solution. Solution function once when we substitute this function over here, and it's going to simplify our entire differential equation, which is linear form. Okay, so I hope this thing is clear, and let's see one more example. Okay, now this is another example. You can see that it is quite clearly following the pattern of your linear differential equation of first order. Okay, p of x is this thing and q of x is this thing over here. X is the independent variable, y is the dependent. That's quite visible. So let's move on, try to find out its integrating factor. So integrating factor is mu of x, the independent variable. All right, so x is the independent variable. That's how the mu is going to be represented. So it is equals to exponential of integral of p of x dx. That's what it is about. So integral of 2x plus 1 upon x dx. Okay, so if I just try to integrate it separately, it can be written something like this. Yeah, it can be written something like this, right? So over here I'm going to get e raised to the power 2x plus ln x. All right, so I can, according to the indices property, we can split this form in this style as well. Okay, so now what I'm going to get here is simply, now you see exponential is going to cancel out this logarithmic effect. So it's just x is going to be left here, and this thing is going to be copied as it is. So I'm getting x times e raised to the power 2x. But this is my integrating factor. All right, this is my integrating factor. Now I'm going to multiply this integrating factor with this equation. All right, I just call it equation number 1 every time I used to forget. Okay. Now let's multiply this thing. So once when we multiply e raised to the power 2x times dy by dx, okay, plus x times e raised to the power 2x plus 1 upon x times y is equal to x e raised to the power 2x multiplied by e raised to the power negative 2x. Excuse me. That's it. Now you can see I can cancel my x with this x. What is left is this thing at the left side, and over here once when you just try to add up these two powers, you're getting power 0. Okay, so just x is going to be left because any base raised to the power 0 gives you nothing but 1. That's why we're having simply 1 here, so it is giving me simply x. Okay, so you can observe now that once when you just take the derivative of product of 3 different functions, okay, so it is going to be expressed something like this. So we are going to follow this style. This thing is expressed in this way, so we have to enclose it in this form. All right, so one function is x, another function is e power 2x, and another function is y here. Okay, so once when we derivate these three functions, then we are going to get this form. You can check it in rough if you want to. Okay, this is it. Now we are going to integrate both sides with respect to our independent variable, which is x. Okay, so we are integrating with respect to x. That's it. Now at the left side, what is left is nothing but product of these three functions. So this thing is going to be left here simply, and over here is left x squared upon 2 plus some constant. Okay, so as we know that y is behaving as an independent variable, a dependent variable here, so y is actually f of x. So we can either stop our work here, that could be our answer as well. But to further refine your answer, you just express this entire equation keeping y the subject. Okay, so y is going to be therefore 1 upon x times 2 e to the power 2x times x squared upon 2 plus some c. Okay, so this is going to be your final form. So this is your f of x. So once when you substitute this f of x over here, it is going to satisfy. This equation is going to be satisfied. All right. So I think that's all for today. So if you find both of these videos helpful, I humbly suggest you or request you to subscribe to my channel, hit on the like, and share this video as much as you can with other learners and with your friends and all that. And don't forget to write your comments in the box below. I'll see you in future with more helpful videos on various other topics of maths. Take good care of yourself. Allah Hafiz.